We are solving a conceptual problem basing on simple pendulum. Let us see what is the problem is. If the iron bob of the simple pendulum is changed to wooden bob, how does its time period gets affected? Right? Let us try to answer that first. So what is a simple pendulum first of all? To a fixed rigid support, we use a inextensible light-weighted string. To that heavy point-edged mass is suspended like this. So, what is the time period of a simple pendulum is? Time period equal to 2 pi into root of L by G. We have already derived this equation. What is L there? That's the length of the pendulum. That is from the point of suspension to the center of the bob. That is L here. Now, have you noticed that it is independent of mass of the bob or size of the bob, even the shape of the bob, but it has to be spherical so that pendulum happens in a simple harmonic motion. But now, when somebody say, I have removed this iron bob and make it like a some kind of a wooden bob or some other metal bob. So what's going to happen? As it is independent of the mass, new time period will still remain the same. 2 pi has not changed, length has not changed, g has not changed. So time period remains same. That's the answer for the first question. Now the next question is this. What is the next question is? If that bob is made hollow, how does its time period is get affected? Now what you want to do is you make this bob hollow. That means empty it up. Empty this. Let's just remove everything and instead of the sphere, you just put a kind of empty a shell, empty ball, something like a plastic ball where inside there is no content. Again the same answer. Why? When you empty it, it's only the mass that gets affected. Its mass becomes less, but the time period still remains the same. So even for the second case, so for the first case, answer remains the same. For the second case also, the answer remains the same itself. Now look at the third case. If that is filled with water, how does the time period is get affected? Now, what are you saying? That is empty bowl is now filled with water. So what happens when they filled with water? Its mass becomes more, but still, as I said earlier, it's independent of the mass. So time period remains the same. Now let us have a look at the next case, fourth case. The water-filled bulb is emptied now. So if you draw the graph, I will just draw the graph once again. This is the bulb. It is now filled with water. And here we have punctured it. So water is leaking out. How does the time period is getting affected, right? So what happens when you leak the water is when the water getting leaked from the bulb is slowly, I will draw another diagram just to tell you how it looks like, right? Slowly what happens is level comes down. So on the earlier it is now completely filled with water. So its center of mass or center of gravity is at the middle. So length of the pendulum is that. Now, as water leaked out, mass also shifts down. So that what happens is its center of gravity also shifts down. So what happens to the new length? It is from the center of this place. Now the center of the gravity has shifted down. So the new length is more than the original. So as the new length is more than the original length, new time period will be 2 pi into root of L dash by G. As L dash is greater than L, T dash is greater than original time period. So when you empty that, its time period will be slowly increasing. But I want you to be a little careful. Up to when that happens, when it is completely emptied, what happens? I want you to understand that. When the bob is completely empty. Now, it is a simple pendulum. This is the bob. It is empty. That means this is hollow. The hollow will have a center of mass again at the center. So the length L double dash will be back to the original length like L itself. So the new time period will be equal to the original time period itself. So in fourth case, it is little bit tricky. You have to be careful in understanding it. What is how it is getting affected. When water is punctured, initially as the water is leaking out, its length increases, so time period also increases. But once if it is empty, center of gravity shifts back to the center, so time period also comes back to its original value. So in the fourth case, what happens is initially, in the case of D, initially time period increases till it is empty, till the last trap, till empty. Once it is emptied, once it is emptied, time period comes back to original value. So all this explains the concept of time period is not dependent of mass, right? That's how you have to understand the problem. Thank you for watching.